Welcome back to Unlocking Innovation, the power of first principles thinking. Today, we're embarking on a journey back in time, over 2 millennia, to explore the ancient roots of a methodology that has revolutionized problem solving. Sam, where does this fascinating concept begin?
Alex, it truly begins in the cradle of Western philosophy, ancient Greece. The philosophical origins of first principles thinking trace back to thinkers like Plato and Aristotle. These aren't just names from history books. Their quest for foundational knowledge laid the groundwork for how we approach complex problems even today. They were looking for truths that couldn't be broken down further, knowledge that couldn't be deduced from any other proposition.
So it's about going to the absolute core, not just making slight improvements. That's a stark contrast to how many people typically approach challenges, which often involves building on what's already there.
Precisely. That's the core distinction. First principles thinking stands in stark contrast to what we call reasoning by analogy. Reasoning by analogy relies on existing solutions and often just makes slight iterations on a theme, usually inheriting potentially flawed assumptions. The ancient Greeks, however, sought to question everything. Aristotle, for instance, formalized this concept. He defined a first principle, or arche, as the first basis from which a thing is known, and a basic proposition that cannot be deduced from any other assumption within a system.
The arche. That's a powerful idea. Can you give us an example of how these early philosophers applied this quest for a fundamental arche?
Absolutely. One of the earliest and most intriguing examples comes from Thales of Miletus, who is widely considered the first known philosopher in Western philosophy. Thales, living from approximately 624 to 545 BC, posited water as the underlying first principle of all things. Imagine that, looking at the entire universe and trying to find the single fundamental element from which everything else derived. It was a groundbreaking leap in thought, moving beyond mythical explanations to a more rational, albeit still speculative, understanding of the world.
Water as the arche. That sounds incredibly simple by modern standards, but the intellectual leap to even ask that question, to seek a single foundational element, must have been revolutionary.
It was indeed revolutionary. These early attempts to define the arche highlight how foundational, yet sometimes incorrect, theory shaped subsequent intellectual history. While Thales' specific conclusion might seem basic now, the method of seeking that fundamental, undeniable truth was what truly mattered. It encouraged a deep understanding of core components and challenged conventional wisdom of the time. This focus on root causes and essential elements is what enables radical innovation, disrupts established industries, and fosters creative problem-solving across various domains, not just in ancient metaphysics.
So, from ancient Greece, the idea of deconstructing complex problems to their most fundamental, undeniable truths was born. It's about questioning all underlying assumptions and then rebuilding solutions from the ground up.
Exactly. Plato and Aristotle sought foundational knowledge that could not be deduced from any other proposition. This commitment to discovering essential truths, whether in natural sciences or metaphysics, set the stage for later philosophical and scientific inquiry. It taught us the value of not just accepting what is, but understanding why it is, right down to its most basic components. It's a method that requires significant mental effort, but the payoff can be game-changing.
It sounds like a rigorous process, demanding intense mental effort. It's fascinating how these ancient philosophical quests still resonate with the challenges we face today in business, science, and even personal development.
Absolutely. The philosophical quest for foundational principles didn't end in ancient Greece. It evolved, adapted, and was refined by subsequent thinkers who continue to challenge accepted beliefs. Next time, we'll fast forward to the 17th century and explore how René Descartes took this ancient concept of questioning to an entirely new level, systematically doubting everything until he arrived at what he considered purely indubitable truths, famously concluding cogito ergo sum.
That sounds like a radical intellectual exercise. I'm looking forward to diving into Descartes' method of doubt and how it laid critical groundwork for modern scientific and philosophical thought. Join us next time for Descartes' Radical Doubt and the Birth of Modern Thought on Unlocking Innovation, the Power of First Principles Thinking. Welcome back to Unlocking Innovation, the Power of First Principles Thinking. Last time, we journeyed back to ancient Greece, exploring the foundational ideas of Plato and Aristotle and their quest for the arche. Today, we fast forward, but not too far, to a figure whose radical approach laid much of the groundwork for modern thought, René Descartes. Sam, tell us about Descartes and his revolutionary method.
Absolutely, Alex. If the ancient Greeks gave us the idea of first principles, Descartes gave us a powerful methodology to find them. He introduced what's known as the method of doubt. This wasn't just casual questioning. Descartes systematically questioned everything he believed to be true, pushing himself to discard any assumption that could possibly be doubted.
Systematically questioning everything? That sounds exhausting and potentially destabilizing. What was the goal?
It was indeed rigorous and perhaps a bit unsettling, but the goal was profound, to arrive at what he called purely indubitable truths. He wanted to find foundational knowledge that could not be deduced from any other proposition, something absolutely certain to build upon. This mirrors Aristotle's definition of a first principle as the first basis from which a thing is known, and a basic proposition that cannot be deduced from any other assumption within a system.
So he kept stripping away beliefs, one by one, until what was left.
Precisely. He found that he could doubt the existence of the external world, the reliability of his senses, even the reality of his own body. But there was one thing he found he could not doubt: the very act of doubting itself, the fact that he was thinking, questioning, doubting. That act proved his existence as a thinking being. This led to his most famous conclusion, his epitomizing phrase, cogito ergo sum, which translates to, I think, therefore I am.
I think, therefore I am. That's incredibly powerful. It sounds like the ultimate first principle for individual existence.
It is. And this radical intellectual exercise, though seemingly counterintuitive, laid critical groundwork for modern scientific and philosophical thought. By starting from a point of absolute certainty, Descartes provided a template for how we can construct knowledge from the ground up, rather than simply accepting inherited wisdom. It was a stark contrast to reasoning by analogy, which, as we discussed previously, often involves solving problems by making slight improvements to existing solutions or accepting prior assumptions without scrutiny.
So instead of asking, how do others solve this problem, Descartes asked, what is the most fundamental truth about this problem?
Exactly. This approach encourages a deep understanding of core components, pushing beyond conventional wisdom. It's about deconstructing complex problems to their most fundamental, undeniable truths, questioning all underlying assumptions, and then rebuilding solutions from the ground up. This framework, identifying and questioning current assumptions, deconstructing the problem into fundamental truths, and rebuilding a solution from those truths, is a core part of first principles thinking.
Are there modern techniques that echo Descartes' method of systematic questioning?
Absolutely. Two prominent examples are the Socratic method and the 5 whys technique. The Socratic method, as developed by the ancient Greeks, is a systematic approach of questioning used to differentiate genuine knowledge from false assumptions. You keep asking clarifying questions until you get to the core of an idea. The 5 whys technique is similar. It involves repetitively asking why to uncover root causes and establish fundamental principles, often going much deeper than just 5 times until the foundational truth is exposed.
So it's about pushing past the surface-level answers to find the bedrock.
Precisely. And while immensely powerful for enabling 10x thinking and game-changing innovation, it's not without its challenges. The source material highlights that a notable limitation of first principles thinking is its demand for significant mental effort and time. It's not a shortcut. Plus, there's the inherent risk of building unstable systems if your initial principles are flawed, or if the inference steps you take from those principles are incorrect. Descartes himself spent considerable effort to establish his indubitable truths.
That makes sense. It requires a deep dive and careful construction. It's about ensuring your foundation is solid before you build anything on top of it.
Right. It allows for the discovery of unconventional insights based on core truths, breaking free from the constraints of existing paradigms. Descartes showed us the intellectual bravery required to strip away everything we thought we knew, to find that unshakable truth, and then to build anew.
What an incredible legacy. From ancient philosophers seeking the arche to Descartes seeking his cogito ergo sum, we see this consistent drive to understand the world from its most fundamental elements. And this drive, this commitment to first principles, continues to shape innovation today. Next time, we'll see how a modern entrepreneur took this philosophy to the stars, literally disrupting an entire industry. We're talking about Elon Musk and how he applied first principles thinking at SpaceX to achieve breakthrough innovations in rocket technology.
That's right, Alex. We'll explore how questioning the cost assumptions of rockets led to a revolution in space travel, much like Descartes revolutionized philosophical thought by questioning fundamental assumptions about existence. It's a fascinating leap from abstract philosophy to tangible, groundbreaking engineering.
I'm looking forward to it. Join us next time on Unlocking Innovation as we explore the tangible power of first principles thinking in the modern world.
Welcome back to Unlocking Innovation, the power of first principles thinking. In our last episode, we journeyed through the foundational ideas of ancient Greek philosophy and how thinkers like Plato and Aristotle first grappled with the concept of arche, the unprovable truths at the heart of everything. Today, we're fast-forwarding to the present day, to a name synonymous with disruption and groundbreaking innovation, Elon Musk. Sam, how did an ancient philosophical concept become a cornerstone of modern entrepreneurship, especially in ventures like SpaceX and Tesla?
That's an excellent question, Alex. Elon Musk is arguably the most prominent modern figure to popularize first principles thinking. He's openly credited this methodology for the breakthrough innovations seen at companies like SpaceX and Tesla. It's truly fascinating how a concept from over 2 millennia ago still provides such a powerful framework for tackling complex modern problems.
So, what exactly did Musk do differently, especially with SpaceX, that demonstrates this approach so clearly?
Musk's application of first principles to the aerospace industry is a textbook example. When he set out to make rockets more affordable and accessible for space travel, he didn't just look for slightly cheaper suppliers or marginally better existing designs. He started by questioning a fundamental assumption. Why are rockets so expensive? The conventional wisdom, or reasoning by analogy, was simply that rockets are inherently costly to build and launch.
And how did first principles thinking challenge that?
Only 2%. That's an astonishing disparity. So what was the next step after identifying that core truth?
Exactly. Once he had that fundamental truth, the path forward became clear, though immensely challenging. If the raw materials were so cheap, the high cost was in the assembly, the supply chain, the profit margins of existing players, and the lack of innovation. His solution, rebuilt from these principles, was to bring manufacturing in-house. SpaceX began designing and building most of its rocket components itself, dramatically reducing costs and gaining unprecedented control over the production process.
And that wasn't the only assumption he challenged, right? What about the rockets themselves?
You're absolutely right, Alex. He then went on to challenge another deeply ingrained assumption, that rockets are single-use vehicles. For decades, rockets would launch, deploy their payload, and then burn up on re-entry or crash into the ocean. This was another huge contributor to the cost of space travel. By applying first principles, Musk and his team asked, what would it take to make a rocket reusable?
Which led to the Falcon 9 and other reusable rockets.
Precisely. He initiated the development of reusable rockets, like the Falcon 9, which can land vertically back on Earth after launching. This innovation, directly stemming from questioning fundamental assumptions and rebuilding from core truths, significantly reduced launch expenses and revolutionized the aerospace industry. It transformed what was once an incredibly expensive, often government-funded endeavor into something much more commercially viable. This ability to achieve 10x thinking and game-changing innovation by discovering unconventional insights based on core truths is a hallmark of first principles thinking.
It's incredible how such a simple yet rigorous approach can yield such monumental results. It truly differentiates between incremental improvement and radical innovation.
It does, and it starkly contrasts with what we call reasoning by analogy. Reasoning by analogy involves solving problems by making slight improvements to existing solutions or simply accepting prior assumptions. If Musk had reasoned by analogy, he might have just tried to buy slightly cheaper rockets or optimize an existing supply chain. But by deconstructing rockets to their most fundamental truths, he enabled a complete reimagining of the industry.
That's a powerful distinction. So, first principles thinking, while demanding significant mental effort and time, allows for radical breakthroughs by avoiding the pitfalls of inherited and often flawed assumptions.
Exactly. It's a challenging methodology, but as Musk demonstrates, the payoff can be transformative. It's about not just doing things better, but doing fundamentally different better things.
And that brings us to our next episode. While first principles thinking clearly drives innovation, what happens when we don't employ it? Next time, we'll explore the trap of analogical thinking and ask a perennial question. Why don't we have flying cars yet? Join us as we uncover how relying too much on existing models can actually stifle our vision for the future.
Welcome back to Unlocking Innovation, the Power of First Principles Thinking. I'm Alex.
And I'm Sam. Alex, after diving into the ancient roots of first principles with Plato and Aristotle and exploring Descartes' radical doubt, then seeing Elon Musk apply it to SpaceX, we've built a strong foundation for understanding this powerful methodology.
Absolutely, Sam. We've seen how deconstructing problems to their fundamental truths can lead to radical breakthroughs. But today, I want to talk about something that often gets in the way of that kind of innovation. It's a common lament I hear all the time. Where are the flying cars? It feels like we've been promised them for decades, yet they're still not mainstream. Why is that?
That's an excellent question, Alex, and it perfectly sets the stage for our topic today, the trap of analogical thinking. While first principles thinking involves questioning all underlying assumptions and rebuilding solutions from the ground up, reasoning by analogy takes a different path.
So, reasoning by analogy, what exactly does that entail?
Essentially, it's solving problems by making slight improvements to existing solutions or accepting prior assumptions without critical examination. Instead of starting from scratch, you look at what's already there and iterate. Think about it. If you want to make a car better, you might add a spoiler, improve the engine's fuel efficiency, or enhance the infotainment system. These are all incremental improvements based on the existing concept of a car.
I see. So with flying cars, are we perhaps stuck trying to make a car fly rather than questioning the fundamental purpose of personal aerial transport?
Precisely. The flying cars example perfectly illustrates how reasoning by analogy can impede innovation. We might be so focused on the form of a car, wheels, doors, engine, and trying to add wings or jets to it, that we miss the underlying function we're trying to achieve: efficient personal transport through the air. An over-reliance on inherited forms rather than functions can blind us to existing solutions, like airplanes, or entirely new possibilities. It's about accepting existing solutions and making slight iterations on a theme, often inheriting flawed assumptions in the process.
That makes a lot of sense. It sounds like this approach is inherently limiting. If you start with a flawed assumption, all your subsequent improvements might still be built on that unstable ground.
Exactly. One of the major pitfalls is that reasoning by analogy often inherits flawed assumptions. You accept the premise of the existing solution, even if that premise is inefficient or outdated. For example, if the assumption is rockets are inherently expensive because that's how they've always been priced by industry, then reasoning by analogy would lead you to try and make existing rockets slightly cheaper.
Which is exactly what Elon Musk avoided at SpaceX, right? He didn't just try to make traditional rockets a bit more affordable.
That's right. He used first principles thinking to challenge the very assumption of high rocket costs. Instead of thinking, how can I make an existing rocket cheaper, he deconstructed it to its raw materials. He calculated that the raw materials constituted only about 2% of a finished rocket's typical price. This fundamental truth led him to the radical decision of in-house manufacturing, completely disrupting the aerospace industry's cost structures. He also challenged the assumption of single-use rockets. initiating the development of reusable rockets like the Falcon 9, which significantly reduced launch expenses. This is a stark contrast to merely iterating on current designs.
So, reasoning by analogy focuses on how do I improve what's already there, while first principles asks, what is the absolute core of this problem, and how can I build the best solution from scratch?
You've got it. First principles thinking encourages a deep understanding of core components and root causes. It allows for 10x thinking and game-changing innovation by allowing for the discovery of unconventional insights. Reasoning by analogy, on the other hand, can prevent that kind of radical departure. It's like a cook who always follows a recipe versus a chef who understands the fundamental properties of ingredients and can create entirely new dishes.
That's a great analogy. The cook relies on an existing solution, the recipe, while the chef builds from first principles.
Precisely. And this isn't just about technological innovation. This type of thinking permeates many aspects of our lives. When we rely on heuristics, rules of thumb, or simply how things have always been done, without questioning the underlying reasons, we're engaging in a form of analogical thinking. It's efficient for day-to-day tasks, but it can stifle true progress and problem-solving in more complex situations.
So, the next time someone laments the lack of flying cars, it might be less about a failure of engineering and more about a failure to apply first principles thinking to the problem itself. We're potentially stuck in a loop of improving a car rather than designing for personal aerial transport.
Exactly. The challenge lies in recognizing when to break free from the comfort of existing analogies and when to dig deeper. It demands significant mental effort and time, and it's not without its risks, as building unstable systems if initial principles are flawed can happen. But the payoff in terms of radical innovation can be immense.
That's a powerful distinction, Sam. It really highlights how much we might be limiting ourselves by simply iterating on existing ideas. It makes me wonder where else we might be applying analogical thinking without even realizing it.
Indeed, Alex. And that's exactly where we'll be heading in our next episode. We'll explore how first principles thinking isn't just for entrepreneurs like Elon Musk or ancient philosophers. We'll delve into how this powerful methodology can be applied in surprising, high-stakes domains, far beyond technology and business, touching on areas like international relations and even simple, everyday decisions.
I'm looking forward to that. Join us next time for Beyond Tech, Diplomacy and Daily Life Through First Principles. Sam, when we talk about first principles thinking, my mind often goes straight to innovators like Elon Musk, disrupting industries with rockets and electric cars. Is this powerful reasoning methodology primarily for technology and engineering breakthroughs, or does it have a broader reach?
That's a common perception, Alex, but it's far from the truth. First principles thinking, while popularized by modern entrepreneurs, is a universal problem-solving tool. Its philosophical origins trace back over 2 millennia to ancient Greek thinkers like Plato and Aristotle, who sought foundational knowledge. And it's incredibly versatile, applicable in domains far beyond tech, including business, science, personal development, and even diplomacy.
That's fascinating. So how does it translate into, say, everyday life or less technical fields? Can you give us a relatable example?
Absolutely. Think about the difference between a chef and a cook. A cook typically follows a recipe, perhaps making slight modifications here and there. This is reasoning by analogy. They're working with an existing solution and making incremental improvements. They might switch out an herb or adjust a spice, but the fundamental structure of the dish remains.
Okay, I see the cook as reasoning by analogy, relying on what's already established.
Precisely. Now, a chef, especially one focused on innovation, uses first principles thinking. They start with raw ingredients, deconstructing the elements of flavor, texture, and aroma down to their most fundamental truths. They question assumptions about how ingredients should be combined, understanding the core chemical and physical properties. From those truths, they rebuild entirely new dishes, creating something truly novel that didn't exist before. They're not just iterating, they're inventing from the ground up.
That's a brilliant analogy. It really highlights the difference between making slight improvements and generating genuine innovation. So the cook accepts the existing recipe as a given, while the chef questions every assumption about the ingredients and their potential. What about a much higher stakes application,
Something like international relations.
That's an excellent challenge. Consider nuclear disarmament negotiations. These are incredibly complex situations, often mired in historical animosities, prior agreements, and deeply entrenched positions. Reasoning by analogy here would mean constantly referring back to past treaties, previous disputes, or existing power dynamics, which can easily lead to deadlock.
It sounds like a perfect scenario for first principles thinking to break through.
Exactly. A first principles approach would involve deconstructing the problem to its most fundamental truths. What are the core motivations driving each nation? Fundamentally, they're often seeking security and stability. By focusing on these underlying, undeniable truths, the first principles of national interest, diplomats can transcend historical grievances. They can question assumptions about how security must be achieved, moving beyond a reliance on weapon stockpiles or aggressive postures.
So, instead of debating the number of warheads based on previous agreements, they'd ask, what is true security, and how can all parties achieve it?
Exactly. By rebuilding solutions from those core needs for security and stability, diplomats can identify mutually beneficial outcomes that might have been invisible when operating within the confines of traditional analogical thinking. It allows for a fresh perspective, enabling solutions that are truly innovative and can lead to lasting peace, rather than just temporary truces based on historical patterns.
That's incredibly powerful. From kitchen innovation to global diplomacy, it seems the underlying framework remains consistent. Question assumptions, deconstruct fundamental truths, and rebuild solutions. But it sounds like it requires immense mental effort.
It certainly does. The source material highlights its demand for significant mental effort and time. There's also the inherent risk of building unstable systems if initial principles are flawed, or if the inference steps are incorrect. Even ancient thinkers like Thales of Miletus, who posited water as the underlying first principle of all things, or Aristotle, who formalized the concept of arche, were engaged in this rigorous, demanding process of seeking foundational knowledge.
So it's not a shortcut, but a deep dive into the essence of a problem. It's about truly understanding the core components to foster radical innovation, whether it's in a recipe, a rocket, or a negotiation.
Precisely. It truly enables game-changing innovation by allowing for the discovery of unconventional insights based on core truths, making it applicable across virtually every domain where creative problem-solving is needed. It's about unlocking that fundamental power of understanding.